Welcome to Ancorum. For thousands of years, humanity has chased one colossal question. What is reality? Is what we see, feel, and touch the real deal?
This isn't real. What is real? How do you define real?
Today, we're rediving into a theory that pulls the rug right out from under our feet. The idea that our entire universe might be a massive, sophisticated computer simulation. What was once a late-night philosophical chat has exploded into a serious debate among scientists and thinkers, thanks to breakthroughs in quantum physics and computing power. And here's where it gets really weird. Once you start looking for it, you begin to see the cracks, the little glitches in the matrix, hidden in the fabric of our everyday lives. This isn't a new idea. Plato talked about prisoners mistaking shadows for reality in his allegory of the cave. But now, we have the tools to explore it like never before. So, let's journey into the rabbit hole. Meet Nick Bostrom, an Oxford University philosopher who reignited this whole conversation. Back in 2003, he published a groundbreaking paper presenting what he calls the simulation trilemma. It's a powerful argument that forces us to accept that one of three very specific possibilities must be true. First possibility, humanity, or any advanced civilization for that matter, will go extinct before we ever develop the technology to create ultra-realistic ancestor simulations. It's a bleak thought, but a definite possibility. The great filter gets us before we get to godlike power.
Everything is dependent on oil.
We are killing for gasoline.
The world is almost out of water.
Now there's the water wars.
Second possibility. We reach that technological pinnacle. We gain the ability to simulate entire universes, but for some ethical, moral, or practical reason, we simply choose not to. Maybe advanced civilizations lose interest in their past. Or maybe they decide it's morally wrong to create conscious beings in a simulation. And that brings us to the third, and most mind-bending option. If the first two are false, if civilizations do typically survive long enough to create simulations, and they do run them, then the number of simulated realities would vastly outnumber the one single base reality. And if that's the case, then, statistically, it is almost a certainty that we are living inside one of those simulations right now. Think about it. One of these three must be true. Are we doomed? Are we uninterested? Or are we digital? That's the trilemma. What do you think? Drop your theories in the comments below. These scenarios aren't far-fetched. Today's computer technology already uses simulations in industrial design, weather forecasting, entertainment, and space research. Technologies like the metaverse show that as computing power grows, our models become more realistic and immersive. Bostrom expands his argument. Once a civilization can create realistic simulations, it will likely start making sub-simulations out of curiosity. This process continues like Russian nesting dolls, layer after layer.
Get away from me, I'm coming down the stairs.
It raises the question, are we the original creation, or is what we call reality just a simulation built by others? The answer might unsettle you. Have you ever dreamed something you were sure was real? What if you never wanted to wake up? How would you tell the difference between the world of dreams and the real one? Imagine we developed an interface that mimics neuronal activity, feeding touch and sensory signals directly into the cortex to create perception.
Hurry. Let's go.
Or suppose you found a way to upload yourself into a biological machine. does a familiar machine come to mind? May it be our brains? Or maybe it is perhaps the entire human body. Throughout history, religions, whether corrupted, forgotten, or ignored, have persistently emphasized an accessible truth beyond the noise. Stages of creation also appear in Eastern teachings like Buddhism and Hinduism, a vast cycle where a person is born, grows, dies, and, depending on their deeds, begins again to atone for past actions. This cycle continues until the person advances to the next stage, just like getting stuck on the same level of a video game. The Abrahamic religions also offer similar narratives. Humans enter this false world as a test, and by reaching higher levels, move to another realm or heaven. Notice how these texts often mention the presence of God or seven heavens. Instead of viewing them as layers of atmosphere or outer space, one can interpret these layers as different planes of reality or levels of simulation. What if these layers refer to the planes of the entity defined as the Lord of all realities, the realms themselves? Many believers expect to move into these other worlds after death. From this perspective, religions could be seen as indirect supporters of simulation theory. Yet because religions frame it philosophically, they lack technical details. We need science's support to solve this mystery. Science and religion, even unknowingly, sometimes point in the same direction. Are we inside a computer program? Is that so hard to believe? Let's start from the beginning scientifically. About 13.8 billion years ago, from a void of nothingness, in an instant, the universe exploded, expanding faster than light, cooling, and forming trillions of galaxies, quadrillions of stars, and countless planets. Look at what we're faced with after 15 billion years. We ask what existed before the Big Bang, and where was space? Religions answer with a creator. There was a creator. Fine. But where was this creator standing? And why did it feel the need to create existence? Neither science nor religion gives a definite answer, nor do I expect one, because the issue lies beyond our logic and perception. Today, the explanation most consistent with both religion and science is simulation theory. It says the universe was always there, but inactive until some force switched it on. At that moment, constants like electromagnetism, gravity, the speed of light, and Avogadro's number were activated, and the existence program began. If you're hearing this theory for the first time, it may sound strange. Still, stay with me. We have strong signals supporting it. So what is real? How do you define reality? If it's what you taste, and those are signals interpreted by the brain. Today's respected scientists, tech pioneers, and philosophers claim we may be in an artificial creation and that evidence exists for it. Philip K. Dick is one of popular culture's most respected science fiction writers. You've probably seen films based on his work: Blade Runner, Minority Report, Total Recall. Dick argued that multiple existences interpenetrate, sometimes leaking into one another, and said many of his books were inspired by visions he experienced. Stories like The Man in the High Castle explore the collision of alternate realities. A related phenomenon we see in the real world is the Mandela effect. Many people misremember historical or cultural details. Examples abound. The Monopoly mascot supposedly having a monocle, he doesn't. Mickey Mouse supposedly wearing suspenders, he doesn't. Pikachu's tail allegedly having a black tip, it doesn't. Or the Volkswagen logos V and W being joined, they're separated by a line. There are hundreds of such cases. Why do millions recall false alternatives as real? Philip K. attributed such errors to bugs in the simulation. Another related phenomenon is déjà vu. The feeling of, I've lived this before. Many explain it as a memory glitch. The simulation perspective sees it as a small reload, an old cache briefly replayed. According to simulation theory, such phenomena arise because we live inside a pre-programmed existence. The event is predetermined, and when you reach it, you recall having done it before, due to a simulation glitch. Your brain may have shown it to you years earlier in a dream or subconscious flash. What happened? A glitch in the matrix. Remember the Mandela effect? There are similar, intriguing phenomena. Another striking example is the origin of the 100th monkey hypothesis. On an island off Japan, some monkeys began washing sweet potatoes in seawater. As their number grew, this behavior spread to unconnected neighboring islands. Researchers noted that once a threshold was crossed, the behavior stabilized collectively. This phenomenon, still under study, shows how an idea or behavior, once adopted by enough individuals, can suddenly gain mass acceptance. Simulation proponents suggest this invisible consciousness leap also arises from interconnected simulation layers. Do the clues end here? Of course not. As claims deepen, new observations continue to support them. As I mentioned earlier, there are trillions of stars and planets in the universe. Yet, we still lack even the slightest clear evidence of extraterrestrial life. According to the Drake equation, considering only habitable zone planets in the Milky Way, even if a tiny fraction support life, there should be about 1 million civilizations as advanced or more advanced than us. With so many possibilities in just our own galaxy, the question arises, where is everyone? This is what we call the Fermi paradox. Are we truly alone in the universe? Mathematically, shouldn't that be impossible? Or is our program focused only on us? Don't we all assume we're the main character in life's game? Could it be that everyone else feels like supporting roles only because the simulation is designed that way? These questions lie at the heart of simulation theory. The silence of the universe, the sheer scale of probabilities, and sudden societal thresholds together suggest that our reality may be just one layer created by another technology or mind. Take Max Tegmark, a cosmologist at MIT. He argues that the very existence of the speed of light as an absolute limit may be one of the strongest indicators we live in a simulation. His reasoning, it resembles the loading screen gamers know well. Enter a new map, and a loading screen appears. Try to skip it, and the game crashes. Simulation advocates suggest the speed of light isn't a universal law at all, but a boundary set by the system to prevent its inhabitants from venturing off-map, buying time to load new regions of the simulation. It doesn't sound so far-fetched. What we know scientifically is that the universe is so vast, it's described as infinite. Yet in truth, it is constantly expanding with a defined structure. Suppose you wanted to move beyond its boundaries. Faster than light, you couldn't, because light speed is the maximum. Yet at certain stages, the universe itself expanded faster than light. In other words, the cosmos surpasses its own physical rules, while still binding us within them. Surprising, isn't it? Another striking example comes from theoretical physicist Dr. S. James Gates. Initially skeptical of simulation theory, Gates studied the smallest building blocks of the universe, quarks and electrons. But his results changed his mind. He said the fundamental structures of matter resemble the mathematical form of the error-correcting codes used in modern computers. These codes detect and fix mistakes during data transfer, according to Gates. The mathematical structures carried by quarks and the particles composing atoms mirror such correction mechanisms. This observation, some researchers argue, strengthens the idea that mathematical codes lie at the heart of existence, combining to create reality. To make this even more concrete, in 2017, A team of scientists deliberately inserted computer code into our DNA. Yes, DNA itself is a kind of code. Our digital codes are 0 and 1, while our biological code is built from a G, C, and T. From this perspective, DNA can be seen as an organic computer code. In other words, we can now create small-scale examples ourselves. Mathematical patterns appear throughout the universe. A beautiful example is the Fibonacci sequence and the golden ratio. The Fibonacci sequence progresses by summing the two previous numbers and manifests in spirals, leaf arrangements, and the structures of galaxies. Such repeating patterns look, to some observers, like traces of an underlying order, or even a code. 0 plus 1 equals 1, 1 1 equals 2, 2 plus 1 equals 3, 3 2 equals 5, 5 3 equals 8. This sequence goes on forever. Dividing successive Fibonacci numbers yields the golden ratio, always converging near 1.618. Many natural structures, flower petals, tree branching, follow Fibonacci numbers closely. Some say it's coincidence that we only see what we want to see, and our brains are wired to find patterns in chaos. True, the brain is good at pattern seeking. Yet dismissing these vast, repeating findings as mere coincidence feels unsatisfying. From galaxies down to the atom, the recurring order suggests not random chaos, but the imprint of an intelligently designed program. The idea of a matrix-like computer-based dream world forces us to consider the need to simulate an entire universe. Such a simulation would require technology far beyond what we have today. Yet, this isn't fantasy. Technology is advancing fast. Moore's law shows that computing power doubled roughly every 18 months for decades. We may now be reaching the physical limits of processors. But humanity doesn't stop. When classical processors approach their limits, new doors open, like quantum computers. With this new power, it's not an exaggeration to imagine that within the next 50 years, everything we know could change. Perhaps with systems thousands of times stronger than today's, especially in fields like simulation and artificial intelligence, progress is accelerating. Think of a personal example. As a child, one of the most advanced games I played was Mario, two-dimensional, filled with pixels. Back then, those graphics amazed us. Today, the realism offered by engines like Unreal Engine 5 arrived only a few decades later. If technology grows exponentially, imagine what the next few decades will bring. So how powerful would a computer need to be to simulate the entire universe? Even with the simplest estimates, a machine would require astronomical power, on the order of 1083 bits or 1080 flops, just to model inorganic structures. Add in living organisms, possible brain states, and consciousness, and the required power multiplies. Running such machines, some calculate, would demand the energy of dozens of suns. This is why some theoretical physicists, like Michio Kaku, argue that simulating the whole universe is practically impossible. I disagree. With enough technology, what is fantasy today can become tomorrow's reality. Kaku's claim that the universe itself is the only computer is one possible explanation. Yet, if the universe and everything in it exist only when we observe them, if existence depends on observation, then simulating a vast universe becomes easier. The key is to set boundaries and ensure entities never cross them, just like in open-world games. Perhaps our universe really does have such boundaries. The double-slit experiment is one of the most iconic studies that append our assumptions about the universe and perception. In short, fire electrons through a single slit, and you get a single band pattern. use two slits with waves, and interference patterns emerge, leaving striped marks on the surface. The expectation is simple. Electrons are particles, so two slits should mean two bands. But the surprising result is this. If no measurement is made, electrons act like waves, forming an interference pattern. Even when the observer leaves the room, electrons still behave like waves. When scientists return, the outcome changes. The observer's presence affects the result. This defies classical physics. Measurement and observation appear to play an active role in determining the outcome. Years later, physicist John Wheeler decided to take the experiment a step further. And the result became a mind-bending paradox in the world of science. Wheeler added advanced sensors to the setup. These sensors didn't observe particles as they passed through the slits, but only just before they hit the surface. In other words, there was no observation at launch. The sensor activated only as the electrons approached the target. When the apparatus was activated, the results turned everything upside down. Electrons initially behaved like waves, passed through the slits, and just before reaching the surface, the sensor engaged. At that instant, the wave-like electrons instantly became particles. Even more striking, although the electron had traveled as a wave from the start, when the observer stepped in, not only the present but its past state was rewritten as a particle. It was as if the electron had gone back in time to re-establish itself as a particle from the very beginning. This was a phenomenon inexplicable by known physical laws. The results showed that observation affected not only the future, but also the past. Since then, this experiment has remained a paradox that the physics community continues to wrestle with, and one that could bring a Nobel Prize if ever solved. Simulation theorists draw this conclusion: nothing in our universe exists until we observe it. Reality itself shapes according to our expectations and perspective. Even sayings like "don't think bad thoughts, they'll come true" may hint at humanity's power to shape its own reality. One of the simplest expressions of this idea comes from the Matrix, the child trying to bend a spoon.
Do not try and bend the spoon. That's impossible. Instead, only try to realize the truth.
What truth?
Do not try to bend the spoon. That's impossible. Instead, realize the truth. There is no spoon. The message is clear. If the observer learns to look beyond fixed physical laws, the observed can also break free of them and bend to intention. But when attention fades, the object reverts. If you can train your mind beyond these molds, perhaps you can bend reality itself, just like the miracles attributed to saints throughout history. This theory suggests that everything we see, from stars to galaxies, are only reflections that don't exist until we observe them. Just like in open-world games, where distant objects only render as you approach. This makes it possible to simulate a vast universe with much less processing power. Just as game characters are bound by loading screens, we too are limited by the speed of light. Instantaneous travel across the universe is made impossible. One of the findings that strengthens this idea is quantum entanglement. Two entangled particles, no matter where in the universe, share information instantly ignoring the speed of light. This shows that in the background code of the universe, there is no limit to data transfer, while characters inside the game, us, are bound by one. This keeps the game running without crashing. In a reality restricted by matter and time's hard physical rules, The absence of such limits on information flow is presented as one of the strongest clues for the simulation hypothesis. Taken together, simulation theory becomes a framework that pushes the limits of both science and philosophy. Its advocates interpret many unexplained phenomena through it. The Big Bang may have been the moment the simulation was first launched. UFO sightings that defy physical laws may be interventions by the simulation's administrators. Humanity's repeated collapses and restarts may be like a game being reset. Miracles told throughout history could be short code edits by the simulation's controllers, and in the end, one question remains. If this is truly a simulation, who built it? Here, science, philosophy, and religion intertwine. Simulation theorists call it a superior mind, while religions call it the Creator or God. In truth, two views that have long opposed each other converge on the same point, though few realize it. In the end, whether we are in a simulation or in a divine order, it means this: one day, when we die, we will open our eyes elsewhere and begin a new adventure. And if this is truly a game, then our goal is clear: to reach the next level and complete it in the best way possible. Thank you for watching. This subject deepens with new discoveries every day. I'd love to hear your thoughts. Share them in the comments. See you in the next video, and take care.